Okay, so I asked you guys to read the case on page 393, and we are making yo-yos, and we have 52 weeks worth of data, and we want to forecast what our demand will be for week 53. So the data is on table 7.1 on page 393, but we're going to take a look at that data, and if you would, if you go to Blackboard, if you go to Material by Chapter, under Material by Chapter, I'd like you to go to Chapter 7. And then toward the bottom, you'll see something called Yoho data. So just to keep this in mind, all your homework and stuff, obviously the data will be given to you in data sets. You don't have to type it in, okay? So no need to do so. Okay. So the data is here. We want to look at it and determine if it is stationary or if it exhibits long-term trends. So I'm going to ask you guys, because we have to figure out, are we using a stationary forecasting model or one with linear trend? What should I do here? How could I do this? What's one way I can look at it and say, what's this look like over the past?
Insert graph.
Yeah, very good. One thing I can do, for sure, is let's graph it. Okay, there's a couple ways I can graph it, but what I'm going to do is let's highlight B1 the whole way down through B53. So select B1 through B53. And then go up to Insert. And there's a chart group. You guys see the chart group here? Click on the line chart. Okay, so it might look a little different on yours, but insert a line chart. And then just choose the two-dimensional line chart. Okay, so a couple things I want to show you, and this is kind of tangential to the material, but right now you'll see, looks like all these things are grayed out. You guys have Excel 2013, most of you? You don't know? 2011? No, there's 2010 or 2013. Okay. Anyways, I'm going to upgrade this file to 2013, so I'll show you how to do that. See, it's in compatibility mode. If you have 2013, I'm going to go up to the File menu and say Convert, okay? Because it's in 2010 mode, just so I can show you all these things, okay? I have to reopen the workbook, so I'm going to reopen it. There we go. Because the file, this book, as I told you, is old, so the workbooks are all stored in 2003 format. So it has to be upgraded to 2013 to use all the features. So you notice if I click on the graph, and this goes for 2007 and up in Excel, if I click on the graph, I get my chart tools back. You guys have chart tools? Okay. So a couple things. I want to fix up this chart a little bit, so I'm going to go to Design. And yours might look a little bit different, but there should be one that says Quick Layout. See a quick layout anywhere? And choose a layout that has a title. So I'm going to choose this first one. Okay, and I can change my title by just clicking on it. So this is demand, and I'm typing demand for Yoho over the last 52 weeks. And then if I want to change this axis title, I click on it and I type units, because I think was just measured in units. So just kind of prettying this up a little bit. What's really nice, I know some of you have taken me for stats or Excel class. What's really great about Excel is, I think the descriptive statistics are very excellent. So under this quick layout, you may not have this, but there's some nice layouts like this one. I think that kind of makes the graph pop a little bit. Very easy to make it look professional quickly. But if you're interested in learning Excel at another level, I am teaching, this is like a paid promotion I put in the middle of my class. I'm teaching an Excel class this summer. It's online. I think it's 11 weeks. And it says advanced Excel with business analytics, but you don't have to be advanced. You have to have basic understanding of Excel, but it'll get you to advanced level. And I think it's a pretty good class. Anyways, okay. If I look at this visually, what do you think it looks like? Stationary or long-term trend? What do you think? Just visually looking at it. It's stationary, right? It's going up and it's going down, but it's not trending up or trending down. So one way I can say that it's stationary is visually looking at it, but someone may determine like, I think it's going up a little bit, or I think it's going down a little bit. So we don't only want to visually assess that, we want to mathematically or numerically assess that. Okay, so visually it looks stationary to me, but I want to also mathematically say it's stationary. So this is how I'm going to do this, and this is a little bit different than the way the book does it, so I want you to pay attention here. I'm going to right-click on this line, okay, anywhere on the line, and it's going to bring up a little dialog there, and I want to go down to Add Trend Line. You guys see Add Trend Line? You see that? Click on Add Trend Line. Okay, and it depends on which version of Excel you have, but if you have 2013, it'll pop this up. If you have 2010 or under, it's going to pop up a little dialog, but it has the same stuff in it. And I want you to put in a linear trend line. And then down at the bottom here, there's two check boxes I want you to check. It says display equation on chart and display R squared value on chart. So I want you to check those two boxes. Game's tied now. Okay, so what that did is it put a trend line in, and it also put in a text box. And I'm going to move this text box. I'm going to put my cursor over, and then when it turns into those four arrows, I'm going to left click and drag just so I can see it a little better. Okay. And I can see a couple things. Visually, I can see, hey, that line looks pretty damn flat to me, right? Stationary. But mathematically, I want to look at two things. This is the equation for that line. And the value before the x value is called the slope of a line, right? And that slope is fairly small, 0.3339x, when we compare it to the magnitude of the y-intercept. So that kind of tells me, hey, this thing is stationary. But what I really want to look at is this r squared value. This r squared value, and this isn't in your book, but this is the way we're going to do it, stands for coefficient of determination. Coefficient of determination. And what it's telling us, okay, it's the percentage of the movement of the y value, which in this case is units, that we can determine by movement of the x value, which in this case is week. And if you look at that number, it's always going to be between 0 and 1, or 0% and 100%. And it's very low here. It's like 0.27%. Very little of the movement of this can be determined by time, which is telling me time is not pushing it up, and it's not pushing it down. Because that value is so low, and usually we say if it's like less than 15%, and here it's less than 1%, we can call it stationary, right? Because time isn't forcing it up, time isn't forcing it down. It's kind of stationary. So the coefficient of determination tells me the percentage of the movement of the y value that can be determined by movement of the x value. So all I've done so far is I haven't predicted a damn thing. All I've said is this thing is stationary. So now, what do we want to know is, all right, it's stationary. Let's look at some forecasting techniques that we can use for stationary models. So I'm going to go back to the slides here. We good with this? Any questions on what we did here?
Is that standard rule, that 15%?
No. That's pretty much, it's not a standard rule. You can have things that only predict 15% of movement, but still significant. In this case, we're going to use 15%. It's one of those things that's not standard. The way the book teaches this, Adam, is it uses regression, and then we talk about like p-values, like, and that's probably a little more statistically savvy. But I found that this is easier to work with and explain. So no, it's not a hard and fast rule, but that's what we're going to use in this class. And I promise you, you'll either see R-squared values that are very low like this one, or you're going to see R-squared values that are pretty damn high. You're like, hey, there's a lot of things there. Okay, so let's then talk about.
So I mean the R-squared value would go up as the more positive and negative that trend line is.
Yes. If it is severe, like if it is that, hey, it looks like it's, wow, it almost looks like a straight line going upward or a straight line going downward, you're going to see a very high R-squared value. Yes. Okay. And I'll show you. We'll do one of those next, all right? I'll probably just make up the data for that, but I'll show you that. So what can we use now to forecast? Does anyone forecast in their job? Anyone forecast anything in their job? Poorly or otherwise? Enrollment? Who predicts enrollment? You, Eric?
Yeah.
Okay. How do you do that, Eric?
Kind of look at previous year's numbers and
Okay.
estimate what we think.
Okay. So how do you estimate that, though? So I don't know what the number was last year. Let's say it was 405. So how do you do that, though? Go ahead.
We've just kind of looked at trends so far this year.
Okay.
Where we've been at this point last year. Are we higher or lower?
All right.
And then either raise or lower that based off of what we are last year compared to.
Okay. So you look at where your applications are and things like that.
Right.
That's good. But before any of those things come in, you know, like if you're at the May of 2000, not May. You just brought in your 2015 class, right? So we're August 2015. Someone says, predict our 2016 class. And at that point, you don't have any inquiries or apps or anything like that for your next class. What would you do then?
At that point, I don't know.
Okay.
What we have.
Well, anyone, what do you guys think? What do you think people use? I mean, what do you use? Does anyone forecast budgets? Well, what you do? All right, you got a 93 on the midterm. If I asked you to predict what you're going to get on the final, what would you predict? Maybe. 75. I've lost interest.
Wheels come off the bus.
All right, wheels are off the bus now. Life got in the way. I've heard them all. Okay, one of the things that we can do, okay, and this isn't, you don't need this class for this, but it's something called, one of the stationary forecasting model techniques we use is something called the last period technique. The last period technique is, hey, whatever it was the last period is going to be my prediction for the next period, right? So if freshman, first time incoming freshman was 415 for this year, that's what we're predicting for next year, right? If demand for yo-yos in week 52 was 500, we're predicting demand for yo-yos in week 53 will be 500. You don't need any kind of template for that, but that is a pretty good method, right? And if you look at what was the budget for office supplies for 2014, well, that's what we're going to plug in for 2015, right? That's a valid technique. Whatever the hell it was last period, that's what we're predicting for the next period. So if I go to Yoho brand yo-yos, and I use the last period technique, what would my prediction for week 53 be? 484. Pretty damn simple, yes? Now, the problem with the last period technique is I have all this data, and it only uses the last one, right? So it's all dependent on the last period. So give me something that can help with that. Give me something, another method that might help with that. What could I do instead of just looking at last week? Very good. A couple things I can do, and this is where we, kind of stat it up a little bit, but we can take an average. And what we call that is a moving average, okay? So you said take the average of all of them. Typically, we don't take the average of all of them. We don't go back all 52 weeks. We could, but usually we take like the last 4 weeks, or the last 5 weeks, or the last 2 months, or the last 3 months. Have you ever seen like a 3-year moving average or a 5-week moving average? It kind of tells you where it's headed, right? So that's the next approach. It's called the moving average method. The forecast is the average of the last n observations of the time series. And it depends, okay? That depends. Like, should I use the last 4 weeks or last 5 weeks? It depends, right? What do you think makes most sense? And I'll talk about how we can quantify that. But what do you think makes most sense in your industry? So something called the moving average method. Now, a little different take on that. So, well, let's look at the Yoho data. So if I was using a 3-week moving average to predict week 53, how would I get the prediction for week 53? If I was using a 3-week moving average, what would I do?
Average 50, 51, 52.
Yes, I would average the last 3 values. So equal, average, and I would say it looks like B51 through B53. Okay. Now, what do you think matters more? So we can tweak this a little bit. What do you think matters more? Things that just happened last week or things that happened 2 weeks ago? Usually. Last week. So instead of, when we do a moving average, like a 3-week moving average, we're giving these all 3 equal weight, right? How can we adjust it to give the more recent values more credence, more of the effect? What kind of average can we do instead of just a plain average? We could do a weighted moving average, okay? So a weighted moving average says apply a weight to those last 3 values. And a lot of times what we do is we use a weighted moving average, and a lot of times it says we use a 3-week moving average. We say give 60% to last week, 30% to the week before, and 10% to the week before that. The weights have to be descending and have to add to 100%. Okay, so what that would look like, and we're going to use templates to do this to make it nicer, but it would look like something like this. Take the B53 value times 60% plus the B52 value times 30% plus the B51 value times 10%. Okay, so that's a 3-week moving, that's a 3-week moving average. Whoop. Using the weights 60, 30, and 10.
Is there a function on Excel to do that?
We could do some product. We could put the weights and then the values and do some product. And we're going to use the template though. Okay. Now the last technique is something called exponential smoothing. Okay? And exponential smoothing we do consider, Beth suggested averaging them all. And we could do that, but typically that's not done with an average. But exponential smoothing is an iterative technique that does start at the beginning, and it forecasts from there, down. So I'd rather just show you to you than explain it, because it is kind of difficult to explain. So let's go to the template. So we know we have 4 techniques right now at our disposal to do this forecast. Last period technique, really easy. Moving average, weighted moving average, and exponential smoothing are the 4 stationary forecasting techniques. Let's go to Blackboard, and let's go to the forecast template. Okay, Chapter 7, forecast template. Let's open that up. Okay, I want to show you how to use this. So go to our original data, which was the Yoho file, and I want you to copy, so I want you to just copy the values. So from A2 down to B53, and click on copy. And then I wanted to go to the template we just opened up, and I want you to copy those values into A12. So I'm going to paste those values into A12. Oops, I'm in the wrong one. I want to go to the simple moving average tab and paste those values into A11. I'm sorry. I was on the wrong tab. Simple moving average, the first one. Okay. I want to put in number of periods of moving average. Let's do 3. And number of periods collected, 52. So what this is doing is the moving average, it's averaging together these last 3 values, 484, 482, 393, and it's coming up with 453 as my forecast value. If I wanted to use a 4-week moving average, all I would do is change this to 4. If I want to use a 5-week, I would change this to 5. We're going to learn to interpret these in a bit here, okay? So just know that this is the forecast value right now. Let's take that same data. So I'm going to take that data, which is an A11, down through, in this case, looks like B62, and I'm going to copy it. And I'm going to move it over to the weighted moving average. And I'm going to paste that data into A12. So this is the weighted moving average, but I need to tell it about the weights. So where I enter the weights, so I want to say 3 periods in the weighted moving average. I collected 52 points of data. And then my weights are, well, the most recent gets 60%, so 0.6. The one before that gets 30%, so 0.3. And the one before that gets 10%. And it tells me my weighted moving average is 474.3. I think that's what we did when we did it manually, right? Okay, the last technique, let's copy this data again. So all 52 of those data points. Let's go over to exponential smoothing. And let's go to number of periods data collected is 52. And this one uses something called a smoothing constant. Okay? A smoothing constant is always between 0 and 1 because it's a percentage. Okay? So let's just put in, and the book will tell you what smoothing constant to use, but let's put in 10% here, so 0.10. Okay, the way this works is it starts with the beginning value, and it figures out a forecast this way. It says, at week 2, our forecast was 236. At week 1, our value was 236, and at week period 1, it was 415. So take 10% of this 415, that's what our smoothing constant says, plus 90% of this 236. And then it goes forecast here and says, take 10% of this 397, 90% of this 397 and 10% of this 348 and come with here. And I want you to notice, a small smoothing constant, you'll notice this forecast value doesn't change a lot. It doesn't go abruptly. So if I made this smoothing constant 0.99, you'll notice this forecast value, 237, then 346, then 272, it's kind of following the value really closely, right? So the smaller the value, the more smooth it is. Okay, so if I put in 0.01, hell, you'll see it doesn't change much at all. If I put in 0.99, that forecast, that blue column, is changing real abruptly. So everywhere between 0 and 1, there's different shades of that. So how much do I smooth it? So if I put in 40%, that means it's taking 60% of the previous value times 40% of the forecast value. But what it's doing here to come up with this forecast, it's called an iterative technique. It starts at the very beginning, goes the whole way down, till it comes up with week 53. So this one does take into account all of our values. So week 53 is 442.231. Okay, you guys with me? Go ahead.
The smoothing constant, like what, like they would give that to you, right? Like that's a.
Yeah, in the book it gives you that. It says use a smoothing constant of 10% or use a smoothing constant of 20%. But if we think about it, it's a good question, right? We just went through like 4 techniques and got 4 different values. So which one should we use? Well, in this class, we like the best way, right? We want to do it the best way. What's kind of nice, and I want to show you this, and we didn't show you this yet, but look at this thing called, let's go to the simple moving average one we did. Now let's go back to, I don't know, let's use a 3-week moving average. Okay. So what's nice is I'm at week 53, right? I'm at end of week 52 trying to predict week 53. So I could say, retrospectively, I could look back and say, you know what, if it was the end of week 3 and I was trying to predict week 4 and I was using this technique, what would I have predicted? Well, I would have averaged these 3 together and I would come up with 333. All right, so what? But now it's week 52. I know what happened in week 4, right? I can compare that to what I would have predicted using this technique. I would have predicted 333. The actual value was 272, so I would have been off 61. Absolute value of how far I'm off was 61. If I square that value, it's 3,721. As a percentage, I was off 22%. Okay, so that's just one value, right? If it was week 5, well, I would have predicted 280. I would have predicted 285, and the actual value was 280. Well, I would have been off 5 or about 1%. In week 6, I would have predicted 300. The actual value was 395. I would have been off 24%. Okay? So we can look at how far off we would have been historically if we use this measure, and then we can assess our errors, right? You look up these little boxes here, there's 4 errors there, 4 measures of how good a forecasting technique this is. I want to focus on one right now. You see the one that says MAPE, M-A-P-E? Yes?
Yep.
That stands for mean, which means average, absolute percentage error. So it's saying if I would have used this technique, on average, historically speaking, I was off 26.8%. Well, let's see if I try this. I change this to, I don't know, 5-week moving average. That's not even better. Let's say 10-week. Is the 10-week moving average better than the 3-week moving average, according to the MAPE? It was 26.8%, now it's 25.4%. Historically speaking, was it better? Yeah, I have less error, yes? So this can help me determine this. So I say 2 weeks, even worse. 9 weeks, it looks like it's a little bit better. This can help me determine the best moving average to use. Now this stands for mean absolute percentage error. Let's go through the other three. They're all measures of performance. The MSE stands for the mean squared error. So it's the average of this column, the squared error. So it's usually a big number. We take the error, we square it, it kind of magnifies it, right? Magnifies it, and then we take an average of it. The MAD, M-A-D, stands for the mean absolute deviation. So on average, how far was I off? So I was off 24%, and on average I was off about 84 units. Second overtime portage then. Whew. So the MAPE is 24.4%. The LAD is the largest absolute deviation. That means if I use this technique, what was the worst I ever was? Okay, that's the LAD, the largest absolute deviation. The worst it ever was 208. So let's compare, okay, let's compare measures. If I use the simple moving average, looks like I'm off 24%. The weighted moving average, better or worse? Looks like it's worse, okay? How about exponential smoothing, better or worse? Worse, right? So these help me assess not only what technique to use, but how good the technique is. And this isn't real good, actually. 27% is not a good forecast. If you're off 27%, that's not too good, right? So typically we have, this data was very variable. A lot of times we get like 2% or 4% or something like that, okay? All right, so those are the stationary techniques. Let us go through a technique for data with linear trend. So I'm going to have to make some data for this. So let's do this. Let's do weeks. Let's just do 10 weeks worth of data. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10. Okay, and I want to put some values here. So let's say, I don't know, let's say 120, 250, 390, 380, 500, 670, 900, 900, 1,000. Say 1150. Okay. All right, so this is 10 weeks worth of data. Let's say we're predicting, I don't know, stock price, okay, perhaps, all right? What I want to first do to determine what type of data I have here, or what time series I have here, is I'm going to take those values, once again, just like I did before. I'm going to go to Insert, Line Chart, and I'm going to choose the two-dimensional line. Okay, now just visually looking at this, what type of time series do I have here? Because I fabricated data that looked that way. Very linear, positive linear trend. Let's validate that mathematically. Remember what I said to do? Right-click on the line, any point. Go down to Add Trend Line. Say Display Equation on Chart, Display R-squared value on chart. It maps in the trend line. You'll notice two things. The slope of that trend line is pretty big compared to the intercept. And second of all, the most important thing is that coefficient of determination is roughly 98%, okay? Which is telling me 98% of the movement of the y value is determined by movement in the x value. So what it's saying is time matters here. You know, time is pushing it upwards. Remember I used 15% as the cutoff? Well, this is way over 15%. So we can say, hey, this thing is exhibiting time series, right? This thing is exhibiting positive trend over time. Okay. So now we know it's time series. What technique do we use? To tell you the truth, there's only one technique that is, there's two techniques in the book, but there's only one that's used in commonplace in the world of business a lot. And that's called something called linear regression. You guys have heard of linear regression? Okay. And actually what we just added in was the least squares regression line. You see that line that we just added in, that dotted line? That's the regression line, and that's the line that best predicts the points. So y is equal to 113x minus 0.0667. Okay? So if someone asked me to predict week 11, how would I use that line to predict week 11? What would I do? X is time, y is the value. If there's someone asked me to predict week 11, I would plug 11 into here, calculate it out, right? If someone wanted me to predict week 20, what would I do? I would plug 20 into here, right? And figure it out. This line is now my forecaster, right? It's the line that best fits those points, and it becomes my forecast value. We're also going to use, so let's copy and paste this, let's copy this data. And I'm going to go to that forecast template again. And I'm going to go to linear regression. I'm going to paste that data. And I'm going to say there's 10 periods worth of data collected. And what it gives me the forecast for time period 11, time period 12, time period 13, 14, 15, 16. If it only goes out for the next, it looks like, what, 12 time periods? If I want to know what the forecast would be for, let's say, week 50, I can use this little box up here. I can type in 50, and it gives me the forecast for week 50. Okay, 5,696. And it still has the same values. It has the MAPE, it has the LAD, and it has the math, all those things. questions on this? The mean absolute percentage error. Okay. Now I promised you guys I would go over the final project. I was going to do that last week and I didn't get to it, so I want to do it this week. So that information is in the syllabus. So let me go to the syllabus and let's talk about that. So it's toward the end. We will present this the last week of class, which, let me see, the last week of class, week 14, April 21st, yes, April 21st. Okay. And in the syllabus, okay, there is a, looks like on page 14, there is a final MBA level group application project. You guys can read that at your leisure, but let me explain to you what I want, okay? This isn't going to be like a research paper where I want you to go and, tell me what queuing analysis is or what forecasting is, or, I don't want that. What I want you to do is I want you to take some problem, some real world problem, hopefully at your workplace. I want you to apply this method, some method that we've learned in class to it, and I want you to analyze the results and say what your recommendation would be. So, an example. Perhaps your area has to forecast enrollment for next year, okay? Well, I want you to say, well, I'm gonna apply these techniques to try to forecast enrollment, show the results, and predict and make a recommendation based on those results. So the components of this are this, okay? So you're going to give me the application description, the setting, the background. So, a lot of people I work for XYZ Corporation, this is what we do, this is how we make money, this is the problem, this is the situation that I'm addressing. The second thing is, what is my model description? Am I going to do a forecast? Am I going to do a project management model? Am I going to do a staffing model? Am I going to do a project selection model? Am I going to do whatever it might be, okay? You have to talk about how you went and gathered your data. And in the real world, data gathering is hard to do, right? Like, it's easy when it's in a textbook. You can say, hey, here's all the information, plug it in, boom, boom, boom. But in the real world, gathering the data and saying, hey, here's the noise and here's the true data, determining the difference between those two, that's difficult to do. So you're going to gather the data, solve the model, show us the output from that, and then make a recommendation. And I want you to do this in the context of you're presenting it to your boss or a board of directors or someone you want to invest in your company. Don't present it to like the professor or the class, right? Present it as if you would do this at a workplace. And people always ask me a couple questions. How long does it have to be? Awful question, right? Because that doesn't matter. When your boss tells you to do something, do you ever say, like, how long does it have to be? No, you don't say that, right? You just say, okay, I'll do it, right? I'll get it done. So, can you do it in a few pages? Sure you can, right? It doesn't have to be a 30-page document. It's saying, what I'm looking for is, hey, here's the, and you wouldn't even do this in the real workplace, but like, this is the organization we work for. You wouldn't do that part, but you would say, here's the issue, describe it, why it's important, all those good things. Here's the data that I've gathered to try to model this situation. Here's the model I use. Here's the results of that model. And here's my recommendation. As a trained management scientist, here's my recommendation. And this is why I'm recommending this. Now, it has to be a paper and it has to be a little presentation, right? So you're gonna do a presentation on that final class day so we can learn from one another. I learn a lot from that day because sometimes you guys apply these models to situations that I wouldn't have thought of. So it's good for me to hear that as well. So not a whole lot, 10 minutes, maybe 12 minutes for that final presentation. You can work in groups or alone. I would prefer you work in at least groups of 2, but if you have, for whatever reasons, you can't work with people very easily, or just can't get together with people very easily, I guess I should have said it differently, you can work alone. You can work in groups of 2, 3, it depends. If there's 4 people that work in maybe the same office, and you say, we have this problem, it's a big problem, we want to tackle it, that's fine. People have also combined models. They've said, I'm going to forecast this, and then I'm going to plug that into, I don't know, maybe a project management model, right? I'm using this to forecast this, or I'm going to forecast this and then plug it into a decision model, right? So you don't have to just use one model. And the other thing is you don't have to just use the techniques that I taught you in class. One of the big goals of this class is for you to think about problems in the workplace and learn how to mathematically model them and solve them and get new knowledge. So it can be something a little bit different. You can say, well, geez, I'm just going to model this with a spreadsheet. Maybe I'm not going to use linear programming. Maybe I'm not going to use one of these templates. But I want you to go through the process of mathematically modeling some issue, right? Some problem. Now, some of you might say, well, I don't work anywhere or whatever it is, but if I think about it, most people forecast something, even in their personal lives. Most people plan projects, right? Even if most people make decisions, like I buy this car, that car, there's things in your life, even if you're not employed right now for a major organization, where you could apply these things, okay? So that'll be graded out of, I think it's actually 35 points. This is wrong, it's 50 points, but it's 35 points. And typically, if you give an honest effort, I grade those pretty easily, I think, okay? I grade those pretty easily. And I want you to use me as a resource. So, after class, if you say, hey, here's my idea, I want you to run an idea by me, because I can usually say, well, watch out for this, or, why don't you look at this aspect, or I can help frame it as well. Dylan, you have a question?
No, it's about like the forecasting model and everything. I'm just curious about it. Keep going. I'll ask you after.
You sure?
Yeah. You want me to ask it?
Yeah, go ahead, ask me.
All right. The values, in the right column.
Yeah.
So just go back to like that, the week or the 52 days or 52 weeks in a year.
Okay.
Like, say you're trying to complete a project. Could that, like, say in your goals, like you said, like, could you per week you get, like,
Trying to find it.
1% done? You know what I'm saying? Like, can you do it by percentages? Like your values be like percentages?
So you're saying,
Like how, like to forecast how long maybe, like, to take to get you to be done with that project, like how long, like you predict it, like say you've done 3 weeks of this project and you're only 30% complete.
sure, you could do that, but you probably wouldn't need one of these models for that, right? I mean, actually, in the field of project management, there's a whole bunch of that. It's called like earned value management is what it's called, and it's a way to track where you're at on a project. So you say like, all right, say I'm building 10 houses, right? And I built 2 of them already, so I'm 20% done, right? But it took me 3 weeks to build them, so I'm predicting it's going to take me 15 weeks. It's called, that's a simplified example, but that's in, if you take the project management course that Mr. Tompkins teaching now, I used to teach, that's called earned value management. It's a little bit, it is forecasting, but it already has these prescribed methodologies. There's something called, and there's something when it's a good course, there's something called CPI and SPI, and that's called the cost performance index, and this is called the schedule performance index. And these values, anything over 1 is good, and everything under 1 is bad. It's telling you, like, are you performing cost-wise above the budget or below the budget? Anything above 1 means you're earning more value than you're spending. And same thing with SPI, ahead of schedule. But there are methods to do exactly what you're saying, but I wouldn't use this. There's a better tool called, and you could use that. I mean, it's not in our book, but it's something that's not real hard to get your mind around. It's called earned value management. And that would be, if you said to me, that's what I want to do for my project. I know I didn't talk it here, but that is a perfectly acceptable project. You know, using it earned value. And it's not, I went through it in a minute, but it's not that hard. I mean, it's like you read a few pages and you understand it. You know what I'm saying? Any other questions? So you can bring up questions if you think about this and think about a project, and bring up questions at our next class as well. What I'd like you to do for homework then, what are we? March 17th. Going fast. I would like you to do, it's the end of chapter 7. I would like you to do 1 and 2, and please, the data for those things are on Blackboard, so don't enter that data in yourself. I would like you to do 21 and 22 and 23. That's one problem, but like a continuation deal. Yeah, and then use 30. You can do all those, okay? Because there really, it's only 3 problems. All right, so have a great evening, and I will see you next week.